Displacement of an object relative to a fixed point O at time t is given by s is 3t to the 4, take away 16t cubed plus 18t squared plus 4. Find the initial displacement of the object. So s of 0 is just going to be 0, take away 0, add 0, 4 meters. An expression for v in terms of t. So we know that v is ds dt, so we need to differentiate. So that's going to give me 12t cubed minus 48t squared plus 36t. The times at which the velocity is 0. So we're going to put 12t cubed minus 48t squared plus 36t equal to 0. So from there we could take out 12t, and then we've got t squared minus 4t plus 3 is equal to 0. And that gives me 12t, and that would be t take away 1, t take away 3, and that gives me that t is equal to 0, 1 or 3 seconds. The distance travelled between t equals 1 and t equals 3. Now from here we can see the velocity is 0 at 1 and it's 0 at 3 and nowhere in between. So the object is going to be travelling in the same direction between t equals 1 and t equals 3. So we don't have to worry about it turning around. So we can do s of 1, which is going to be 3 take away 16, add 18, add 4. So that's going to be 2, 5, 9. And we can do s of 3. Let's do that on the calculator. So that's, if t is 3, that's going to be 3 times 3 to the 4. Take away 16 times 3 to the power 3. Add 18 times 3 squared. Add 4. And that's negative 23. Oops, not quite sure what happened there. Negative 23 meters. And so the distance is going to be the distance between these, which is going to be 23, add 9, which gives us 32 meters. An expression for the acceleration in terms of t, so the acceleration we get from differentiating the velocity, so that's going to be 36t squared, take away 96t, add 36. We should really use units here, so this is in meters per second squared, and of course this one up here is in meters per second.